I may have figured out the secret to Tesla's trimetal generator. It's this Bosch line that's in between the North Pole and the South Pole of a magnet. It's the vibration, it's the it's the motion in space, the vibratory reciprocating motion in space between the North and the South Pole in which we wiggle this Bosch line. We cause it to wiggle. Now, how do we do that? Well, paramagnetic means to repel a magnetic field. Diamagnetic means to absorb it, and or attract it, and ferromagnetic is to generate it in the first place. So, let's take out William Lyon's description of Tesla's special generator from the version that the Nazis used in their electro U-boats. Let's take out the compressed air, okay? Because I've already gave the supposition on energetic form, this list, the energetic form thread that I started that nobody has replied to for the most part. Nobody's coming up with any ideas. Okay, so I have to answer my own questions. It takes some time then if you're going to be the only one answering your own questions. So I already put up the supposition of using a quartz crystal in place of the compressed air to cause reciprocation of the piston. Now, what if the piston is not a piston anymore? What if it never was? What if it's a rod, not a piston? The piston, we think it's this tiny little short thing. Now, William Lyon said it only has to reciprocate a 1/16 of an inch, so let's keep that. But let's not forget about this idea of a piston. Think of it as a rod extending beyond the cylinder it reciprocates inside of. Okay? Why? Why do we want to do that? There's a material reason why. Because we want to make sure that the aluminum rod extends beyond the Bosch line. What Bosch line? Well, we put an iron spring at either side. We have two iron springs. One at either side, one at either end of this aluminum rod. Now I'm going to presume that it's reciprocating inside of a copper tube, okay? And there's oil serving as a lubricant, but also as a dielectrical separator between the copper tube and the aluminum rod. But we also have to have dielectrical materials attaching the aluminum rod to the iron springs. I'm assuming, maybe not. It may not be necessary, okay? Because William Lyon said that Tesla was looking for a substitute for iron. That aluminum, Tesla felt, would substitute for the function that iron normally functions for us. Okay? So, I put the aluminum in the center between the two fields of the two iron coils, which also have iron cores to them, because they are going to generate a magnetic field of a north pole on one end and a south pole at the other group area. And the aluminum rod is reciprocating between them, attached to those two springs. Okay? And there's going to be a quartz crystal at one end. And we're going to have clones of this hooked up in series. Okay? And all of the quartz crystals have to vibrate in unison. Sorry, got an itch in my ear. I would think. Okay? So if you had compressed air, they have to be valved to reciprocate in unison with each other. But there's springs, so there's kinetic motion. A lot of these free energy devices are a mix of two different mediums. Kinetic energy and electrical energy, let's say, is a good example, like Jim Murray's transforming generator, for instance. So this is one of those instances in which we are doing that, but we're focusing on the Bosch line. We're putting in a paramagnetic material, the aluminum rod, in between two fields that have opposite polarity of magnetism. Okay? So we're going to create a Bosch line between them, artificially, because these are electromagnets. We might use magnetic material as the core of the two iron springs, but maybe not. Let's just say they're ferromagnetic material. They are magnetizable. Let's assume that for the moment. So what is the aluminum going to do? It's going to repel the magnetic field. The Bosch line that's supposed to form there is not going to be allowed to form there. Okay? It's going to be pushed out. And worst of all, it's going to be vibrated at a very high frequency. Okay? The frequency that Eric Dollard said in his presentation, in which you get various anomalies begin to occur. And it varies, but it seems to be in the kilohertz range. It might be, I don't know, 20 kilohertz or something. You know, it varies depending on your setup. But there's a cutoff point. And when you go beyond that, you know, when you chart the thing, you measure what's happening, things start to happen very weird. They start to plateau, or the lines separate on your graph of what you're plotting. It's a phase transition area. So let's assume that the reciprocating, the rate of reciprocation, the oscillation frequency, is somewhere in the kilohertz range. Okay, not something tremendous like megahertz or any gigahertz, nothing like that. There could be multiple transition points, and kilohertz is the lowest one. But Eric Dollard did say if you get something too slow, it doesn't behave the way you want it to with this energy that Tesla was trying to seek. Instead, it behaves like normal conventional electricity, and that's what we have, 60 cycles in North America. So you get conventional electricity at 60 cycles. And when he wanted to study the Alexanderson network, he had to take it up into the kilohertz range to find the first break-even point at which things began to behave in a way different than conventional electricity. So I'm going to assume that the first optimal operating frequency for this Tesla special generator is in the kilohertz range. Okay. What else? So we're vibrating the Bosch line because we're reciprocatingly, alternately moving this aluminum rod between the two iron fields, the two ferromagnetic fields. We're oscillating the paramagnetic between them. And then we're picking it up with a copper winding surrounding it. Now, should it be an aluminum tube that this aluminum rod is reciprocating inside of? I don't know. Should it be a copper tube? Should the winding be made of copper wire, or should it be copper-clad aluminum? Eric Dollard did mention that copper-clad iron wire is used by the power company because you don't need the copper on the inside. Maybe it wasn't the power company. Maybe it was the Alexanderson antenna. It was somewhere where you don't need the copper on the inside when you step up the frequency high enough, because you really don't have much current at that point. It's mostly a frequency voltage oriented phenomenon. So I'm guessing that the same thing is happening in Tesla's special generator, which means that it may not be optimal to use solid copper wire. Now, how did they create this kind of wire back in the 30s, you know, when this was designed, or prior even to the 30s? I don't know. I have no idea. What this means is that Tesla was an empiricist. He did the experimentation, even if his theory, we may disagree with his theory in hindsight, which means that if he didn't have the opportunity to make the experiment, then he wouldn't learn. And if he doesn't have the materials with which to make the experiment, then, So I'm wondering, all of this discovery of Tesla's special generator might hinge, ultimately, or in its finality. The compressed air came prior, but now we have piezoelectric crystals, which we discovered during World War II. So we don't need the compressed air. But the real fundamental hook that all of this sits upon may be a wire that is clad, an electroplated, you've got a solid core, let's say aluminum, and you electroplate copper on top of it, a very thin veneer of copper, or silver for that matter, silver-clad copper wire. I think there is such a thing. So you want different resistance characteristics between what you clad the material that you use to clad the core and the core itself. You want the core to be far less resistant so that the electricity wants to go to the surface of this wire. In fact, you could use glass, and it's not that hard to clad glass. You could get a glass tube. So we could have, in theory, this reciprocating rod inside a glass tube. There you go. A glass tube. And the outside of the glass tube may be clad with something. What would it be clad with? Iron? To pick up the Bosch line and spread it across its entire length? I don't know. The easiest thing to clad it would probably be something other than iron. I don't know if iron clads that easily. Electroplates that easily. It could be aluminum, in which case you're setting up a capacitor, because you've got the aluminum rod on the inside and the aluminum clad glass tube on the outside. You've got yourself a condenser in which the inner plate is vibrating. So that might be how Tesla came to this, was he figured out to take a condenser and vibrate one of the two plates. And then throw in the other stuff, which became part of the dynamics, the iron and the copper. So we might have, instead of the copper winding around the middle, we may have it at both ends, two copper windings, one at either end, an iron core spring on the inside of the copper windings. So it may be a solid copper wire winding, two of them, one at each end of this aluminum rod, which vibrates inside of a glass tube, which has aluminum veneer electroplated onto the outside surface of the glass tube. There's oil on the inside to set up another dielectric between the aluminum rod and the glass tube, but also is to serve as a lubricant, but also a dielectrical insulator. So you got the two copper windings at both ends creating opposing fields that are oriented, opposed. One is north with respect to the other, which is south. They're opposite. Now, do they pulse at the same time? Probably not. Probably not. They alternate. So they're not only opposite in orientation, but they alternate pulse. So the duty cycle might be 50% for one while the other one is off, and vice versa. Now the core, if there is a core to these copper windings, where else are you going to put the iron? They probably have an iron core, which might be an iron spring. Okay. To store the energy of this reciprocating rod and deflect it back so you conserve. If he just had compressed air, you're wasting energy, because you have to use compressed air at the opposite end to slow down, stop, and reverse the motion of the aluminum or of the piston, whatever the piston is made of. But if you put a spring there, you conserve your energy. You don't have to use so much compressed air anymore. So I think he used a spring at either end. William Line never thought of this. Tesla was big on efficiency, and all the details matter. So if we put a spring at either side, we conserve kinetic motion. We won't lose it. We'll be storing it. So it'll take so little compressed air or an oscillating crystal, quartz crystal, to get this thing vibrating and maintain its vibration. So it takes very little energy. So it's just like everything else Tesla does. You start the child swinging on the swing. The guy, I can never remember how to pronounce the guy's name. He's got this weighted pendulum at the long end of the arm of the pump, the lever. And he swings the thing with his pinky, and he's able to, pump water. So Tesla thought the same way. You start up oscillations with very little energy. Bedini's Energizer is the same thing. You give it a little push, and it slowly increases speed. Jim Murray's transforming generator, the same thing. it picks up speed under certain conditions. It accelerates to infinity and then wants to burn itself up. So this thing of self-induced augmentation is a very cool concept if you can make use of it. And I think that's what Tesla did here, because he used a spring to conserve his momentum, store it, release it, and require very little energy to add to the system based on what he's losing. Okay, so he just enough to cover his losses. All right, Bedini likes to, was it? No, it was Jim Murray describing the transforming generator. That's right. It needed very little energy to cover its losses. That's right. So, unless we put a copper spring inside of an iron wound winding. I don't know why you would want to do that. Usually you don't make a copper spring, do you? Iron takes structural force much better. Or does it respond to high frequency? Oh dear, I wonder if it has to be an aluminum spring. You know, I don't know. Well, if we don't put a copper winding around the central shaft, around the entire length, but we're only doing these windings at both ends. What if all your three No, you've already got aluminum on in the middle, so you don't want aluminum at both ends, because we want to push the Bosch line away from its middle and shake it at the same time, destabilize it. Yet we want to compress it at the same time. So that means we have to have an iron core, copper wound electromagnet at either side. So what do we make the spring out of? And where do we put the spring? It may be a... No, wait, didn't I say I was going to put a pancake coil in the middle? Oh yeah, that's right, I did say that, didn't I? Oh, the pickup coil, that's right, we need 3 coils. So we need a pancake coil. Actually, we may need 2 pancake coils that are wound opposite, either in line with each other or next to each other. Probably in line, because that's the way he did it, Tesla. So we have a double wound, a bifilar pancake coil in the center, which is the pickup, the secondary. But then we have 2 primaries generating the field in the first place, and those are at both ends. Okay, so we have 3 coils. So we have to worry about how the construction, the manner of construction, what kind of wire is used in those 3 coils. The central one, of course, has no iron core. It's got the aluminum as its core. But the 2 at the other end, at each end, they have an iron core. And they also have to incorporate a spring, which might serve a double duty if it's both the core and the spring inside the copper winding. That would make sense. To me, anyway. We could conceivably put a quartz crystal at both ends, because it's alternating duty cycles, so it could be that while one is on, while one is on at one polarity, the other's off, or reverse polarity. Yeah, it's reversing polarity is what it's doing. So the silicon quartz crystal is acting like a capacitor, but then so is the aluminum, so is the glass shaft, so is the glass tube. That's, that's a capacitor. I wonder if the pancake coil has to be constructed in a very special way. Would you immerse it in oil? Would you space the windings on the pancake coil, not compress them? So the 2 coils at either end are compressed together, tightly wound, just like you would do an electromagnetic coil winding. But the pancake coil in the middle is separated. There's a space of separation between the wires as you wind out in this pancake coil to create a capacitance between the wires. That would make sense. And it has to be bifilar because it has to be two opposing fields encapsulated within one pancake coil. Okay. What else? Oh, is there a third wire, the trigger wire? A trigger coil? Holy crap. Of course. How else are you going to regulate the damn thing? It has to change its pitch based on the based on the change in the kinetic motion, or the kinetic reciprocating motion. That's right. You can't use brushes. You've got to have a trigger coil. But he didn't have did Tesla have transistors? What would he have used instead of a transistor? I wonder if there's a substitute. You know, I think I dimly remember there is an alternative with the use of vacuum tubes, that you could have a transistor setup in your circuitry. He might have had a trigger coil. See, I knew it. Beanie and Cecil. Bedini Genie. Bedini the Genie has a trigger coil along with two coils. Why did he have two coils, if I can recall? See, I'm not a student of the schoolgirl motor that much. Anyway, he had a trigger coil, and I think that's what's inside this pickup coil, this secondary, this pancake coil, is a trigger coil. So it's going to be three. It's not going to be bifilar. So two are not oppositely wound, I think they're wound the same. They're oppositely oriented, oppositely wired in the circuitry that feeds it's connected to. But there is also a trigger coil and some kind of a transistor setup, because you've got a duty cycle. You've got two different coils on either side. It's very much like a Bedini circuit, in which you've got opposing coils. He's got rotors, gutless wonders, in which he's got opposing action between a pair of coils on either side. But usually it's a rotating drum or a rotating bicycle wheel, not a reciprocating piston situation or a reciprocating rod. So this is beginning to sound very interesting. So we use Bedini to figure this thing out. But it is a materials logistical thing, but it hinges on vibrating the Bosch line, disturbing it, deflecting it, as well as disturbing it, by using a paramagnetic material in the middle of this situation, and nothing else can be in the middle. Well, no iron can be in the middle, let's put it that way. It has to be at either end. Maybe we can put copper in the middle, but definitely no iron, because we want to vibrate this Bosch line, and we want to disturb it, in other words, but we also want to deflect it, and that's the purpose of the aluminum. So if we deflect it into a copper winding, that's what the pancake coil is. The pancake coil is going to be a copper winding. So there's no fancy clad wire. The clad is the condenser tube that all of this is arranged inside of. So he's got a vibrating condenser tube in the middle of a magnetic field to vibrate the Bosch line and disturb it and deflect it, because it's an aluminum-based capacitor, which is not unusual that your plates are made out of aluminum. And one, in this case, is stationary, the coating, the clad on the exterior of the glass tube, versus the rod on the inside that's reciprocating between the two fields. So there you go. You got to have something in motion, an aluminum object in motion in a magnetic field. That's the whole arrangement of a watt-hour meter. An electromechanical watt-hour meter is a piece of aluminum moving in a magnetic field. Because if you look at, like, what my old my old mold meter from 1910 or 12, I forget the date. I think it's 1910. besides the two coils, the voltage coil and the amperage coil, there's also an armature around this whole thing at the back end. And both coils are wound around arms of that armature. The voltage coil and the amperage coil are connected to the armature, and the armature surrounds the rotating aluminum disc inside this watt-hour meter. So you see, I'm trying to uphold what I learned, what little I learned studying the watt-hour meter. There's certain characteristics that have to be repeated, and William Lyne said, you know, it's a model to judge by how to solve the problem. And so I think this is what it is. The way to go about looking at it. Anyway, I've used up all my ideas. I think they're cool, though. I think they're really cool. Maybe no one will agree with me, but hey, I will never let go of this, just like I'll never let go of wanting to get my son back. But, you know, it doesn't mean there's any guarantee of success in any case, but it doesn't mean I'll let go either. It's just, you know, just because I can't come up with the answers right away doesn't mean I haven't let go. I'm still holding on. Despite the criticism. Oh, it's a waste of time, Vinny. You know, well, you tell that to my friend who lives up in Packwood, Washington, who met somebody in the Midwest years ago, 10 years ago at least, who was an electrical engineer who came up with what looked like a solid-state unit based on iron, aluminum, and copper. Tesla's special generator. And it ran a motor. You know, a nice-sized motor. And it was the size of a notebook. So this would have been post-World War II, which meant he might have known about the use of using an oscillating quartz crystal in place of the compressed air that William Lyne describes that Tesla had designed, or the Germans had designed, into their electro U-boats. And if you have these pistons set up in series electrically, but oscillating in opposite, half of them operating, you know, the pistons going one way while the other half, the pistons going the other way, at a high ultrasonic pitch, right? 20,000 cycles per second is beyond our hearing. You won't hear it, and you won't feel it because the motion of each rod is going in the opposite direction to its paired twin. Its counterpoise twin. So it'll appear to be standing still. So you won't hear it, you may not even feel a vibration, or you might feel a hum if you held it. But if he held it in his hands and he let nobody else touch it, they'd never know. Because they won't hear it, and they won't sense any motion, because they're not touching it. Just the wires, the cables leading to it from the motor, vice versa. So it's conceivably possible that nobody would get the hint as to, oh, there's something vibrating in here. Ooh, you know. Quartz crystal maybe, you know, driving the thing. Ooh, you know. So nobody would know. And nobody would hear it because it's ultrasonic. It's a vibration above human hearing, above 20,000 cycles per second. So that's what my guess is. I guess now I've covered everything.